Welcome back to this microservice architecture and design pattern series. Traditional systems store only the latest state of an entity. As a result, valuable business history is lost, making it difficult to audit changes, investigate issues, reconstruct past states, or replay business processes. Event sourcing solves this by storing every state change as an immutable event, creating a complete and reliable history of the business transaction. Let's consider a traditional order service. When an order is created, shipped, and eventually received, the database typically stores only the latest state of the order. Questions like when it was created, when it was shipped, what sequence of events occurred become difficult to answer. This lack of historical context makes auditing, debugging, and rebuilding the system state challenging. The event sourcing pattern solves this problem by storing every business change as an immutable event. Instead of saving the current state, we persist events such as order created, order shipped, order received. The current state can then be reconstructed at any time by replaying those events in sequence. I've created a blank solution called event sourcing. Let's add a class library project to this solution. Let's call it as domain event lib project. Let's add an abstract business object class to this class library project. Let's call it as business object. It will have two properties, an ID of type integer and status string. Let's add the order business object class to this library. It will extend from the business object base class. Let's add a generic domain event class. Now here T will be the business object on which the domain event occurred. Let's add few properties to this domain event class. Let's add a GUID to uniquely identify the event. Let's add date time to mention when the event was created, the business object itself, and name of the event, and an abstract method called apply. Now this apply method, once applied on the business object, will give the then state of the business object. Let's add few domain events to this library. Let's first create a class to represent the order created event. Now this will be a domain event for the order business object. Let's add the name property, as well as let's implement the apply method. Now when order created event is applied, then the ID is initialized. Also the status of the business object is created. On similar lines, let's add the OrderShipped event. This class will represent the shipment of the order. The status of the business object will be shipped. Let's add OrderReceived event as well. We implement the apply method and the status of the order business object will be received. Let's add an interface to represent the event store. Once business transactions are taking place, we'll store the events in this event store. Let's call it as I event store. It will have methods such as save, which will take the domain event in the input. It will also have a method to get all events for the corresponding business object. It will also have the apply method, which will apply a collection of events to the business object. Let's add a class to implement this I event store. For the demo purpose, we'll use in-memory event store, but this could be a separate microservice with its own database. Let's call that class as in-memory event store. We'll store the events as a list of domain events locally. Let's implement the save method. We'll simply add the incoming event to the local collection. Let's implement the getAllEvents method. We'll simply filter out the events based on the input filter and return the IEnumerable. Let's implement the apply method. We'll get all the events in the input for this method and apply those events sequentially on the incoming business object and return the business object. Let's add a web API project to this solution so that clients can send those events or get the events applied on a particular business object. So let's add new project. Let's call it as domain API project. In this web API project, let's add a class called OrderRouteExtensions. This class will have methods for each of the order related route. Let's add a method called mapRoutes. Let's add another method for map create order route. Let's implement this method. We'll add a post endpoint called OrderCreated, and we'll simply store the OrderCreated event once this endpoint is called. Similarly, let's add a map ship order route. This will expose an endpoint for shipping the order. Similarly, we'll save the event in the event store. Let's add another endpoint for receive order route. We'll add the required references. Let's add another class called event sourcing route extensions. Now this class will expose endpoints related to event sourcing. This could be a separate microservice, but for the demo purpose, we'll add the endpoints in this project itself. Let's add a method to expose the hydrate route. Now hydrate route will take the ID in the input, and then it will get all the events associated with that object from the event store and then apply those events sequentially on the object, so that at the end we'll get the complete hydrated object. Similarly, let's add a replay route. The purpose of this replay route is to get the ID in the input and then return the events as a async enumerable. Now why we are using async enumerable, this will be clear in a minute. We'll simply replay those events in the browser. We'll get all the events from the database or event store and return those events in the response. Let's modify the program.cs of this API project to inject the required services and allow the CORS access for the HTML page. Let's add the event store as a singleton service. Add CORS so that the local HTML page can access this API. And let's add the hydrate as well as the replay routes. Now to display those events replayed in the browser, let's add a new HTML page to this solution. Let's call it as client.html. Let's add a very basic UI logic to this HTML page. Now within the script tag, we'll hardcode the stream URL for now. This is where the events will be replayed, or a replay of the events will be available. We'll simply display it in the browser. Let's add a stream response method. This will get the response content element from the HTML page. It will read the response from the URL, and then while the response is available, remember we mentioned that the response will be async enumerable, so it will simply have that replay kind of effect in the browser. Okay, so while the response is available, we'll read the response and then append the response data to the inner HTML of this response content tag. Now how do we pass that data? We'll use text decoder available in most of the browsers. We'll decode its value, apply some basic formatting to the response string, and convert it to a list element. As soon as the page loads, we'll make a call to this response method and we'll get the output of the UI. Let's add the HTML elements. Let's run the API project using .NET Run command. The API is now listening on port 5135. Let's send few requests to the order routes. Let's first send a request to the OrderCreated route, then send a request to this OrderShipped route, and finally send a request to this OrderReceived route. Now we want to replay those events as sequence and view them in the browser. Now let's right click on the HTML page and click on Browse with. Let's open a Firefox browser instance. Now as you can see, the events will be played as a sequence. Now that we have walked through the implementation, the key idea behind event sourcing becomes much clearer. Instead of storing only the latest state of an order, we persist every significant business change as an immutable event. In our example, the order service records events such as order created, order shipped, and order received. This gives us something traditional CRUD systems cannot give: a complete history of what happened and when it happened. We can replay those events to rebuild the state, investigate issues, and recover projections. The current order state is no longer the primary source of truth. The event stream is. Event sourcing is especially valuable when auditability, traceability, and historical reconstructions are important. It also enables powerful patterns such as replay, temporal analysis, and rebuilding read models. Of course, it comes with trade-offs. You need to manage event schemas, versioning, and replay strategies carefully. But for systems where business history matters, the benefits can be significant. To summarize, store the events, derive the state. That's the core mindset shift behind event sourcing. If you liked the video, please give a thumbs up and subscribe to continue receiving more videos for microservices architecture and design patterns. Again, thank you for watching.